So our objective today for Algebra 2 is to write equivalent forms for exponential and logarithmic functions. So a logarithmic function is just an exponent. So a logarithm is the exponent to which a specified base is raised to obtain a given value. And what we're going to focus on in this first part is rewriting from exponential to logarithmic. In exponential, it's written b to the x equals a. b is the base, so the base to a power equals a. In logarithmic form, it's written log base b of a equals x. The b is the base, the a is the answer, and x is the exponent. So the way this is read again, it's read as log base b of a equals x. So we read that as log base b of a equals x. So we're going to work through this table, and it's just rewriting. So the first one, 9 to the second power equals 81. So 9 to the second power equals 81. So in logarithmic form, we write log. Our base is the same as the base over here, which is 9. So log base 9. And you go right around in a circle. So log base 9 of 81 equals 2. So log base 9 of 81 equals 2. So let's look at the next one. 3 to the third power equals 27. We write log. Our base is the 3, and you go around in a circle. Log base 3 of 27 equals 3. So the next problem is the reverse. This time we have it in logarithmic form. We have to write it in exponential. So log base 3 of 243 equals 5. Start with your base of 3 and go in a circle. So 3 to the fifth power equals 243. So the next one, log base 25 of 5 equals 1/2. Our base is 25. So 25 to the 1/2 equals 5. So the next problem, 10 to the fourth equals 10,000. As a log, it's log base 10 of 10,000 equals 4. Log base 6 of 1/6 equals -1. The base is 6, and you go in a circle. 6 to the -1 equals 1/6. A to the b equals c. As a log is log base a of c equals b. 4 to the -2 equals 1/16. As a log, it's log base 4 of 1/16 equals -2. Now when we get to this next one, log 1000, there should be an equals 3 behind it. I left that off. It was a typo. Now, you'll notice on this one there's no base. And the reason that is because log 1000 is called the common log. And the reason it's called a common log is because it has a base 10. So it's the common log because it's base 10. It's kind of like when we write an x and we don't put the 1 in front of it, or we write the x and we don't put a 1 for an exponent. It's unwritten. So log 10,000 equals 3 means log base 10 of 10,000 or of 1,000 equals 3. So anytime there's no base, it's a 10. So log 1000 equals 3 as an exponent means 10 to the third power equals 1,000. Okay. So 9 to the first power equals 9. As a log would be log base 9 of 9 equals 1. Excuse me. Log base 2 of 512 equals 9 would be 2 to the 9th equals 512. Now in this next section we're going to be evaluating each logarithm, and what we're going to do is rewrite it as an exponent, and we're going to use our calculator to find the answer. So problem number 1, log of 0.01. We're going to first put this equal to x, and we're going to rewrite it as an exponent. To rewrite it as an exponent, our base, it's not there, so it's a 10. So it's 10 So we rewrite this as 10 to the x power equals 0.01. And we have to figure out what that x is. And now the easiest way to do it is to use our calculator. And because our base is a whole number and our answer is a decimal, that means that x has to be negative. So what I do is I try 10 to the negative 1. Okay, that gave me 0.1, not what I need. So I try 10 to the negative 2. And that did give me what I need. So my answer is x equals negative 2. So let's try number 2. Log base 5 of 125, I put equals x, and I write it as an exponent. 5 to the x equals 125. And then I tried in my calculator. 5 to the first is 5. 5 squared is 25. 5 to the third power, 125. So x equals 3. Number 3, I put equals x. So 5 to the x equals 1/5. Because this is a whole number and that's a fraction, that means that x is going to have to be negative. So I'm going to try 5 to the negative 1. Now that gave me a decimal, but I want to know if it's a fraction. So I hit math, enter, enter, and it's 1/5. So there's my answer, x equals negative 1. So number 4, there's no base, so this is 10 to the x equals 0.00001. So 10, because that's a whole number and that's a decimal, I know it's going to be negative, so I'm going to try negative 1, negative 2, negative 3, negative 4. Oh, and now I got an e. That 1e negative 4 is scientific notation. So that means 1 times 10 to the negative 4. So that's 0.0001. So let's try 10 to the negative 5, because I'm not quite there. And there it is. So x equals negative 5. Number 5, log base 25 of 0.04 would be 25 to the x equals 0.04. This is a whole number, that's a decimal, so that means my answer has to be a negative. So 25 to the negative 1. Did that give it to me? Yep, so x is negative 1. Number 6, log base 2 of 64. 2 to the x equals 64. Well, I know it's not going to be 1 or 2, so I'm going to start at 3. So 2 to the third, 2 to the fourth, 2 to the fifth, almost there, 2 to the sixth. There we go, 2 to the sixth is 64, so x equals 6. We're going to add one more problem here, number 7, and it's going to be log base 2.5 of 6.25. So that means 2.5 to the x equals 6.25. Now when I look at this and I see 2 decimals, that means that x is going to be positive. So I'm going to try it in my calculator. 2.5 to the 1, 2.5 squared, oops, helps when you type it in right, 2.5 squared, 6.25, so x equals 2. Okay?